know this. He rep the homosocius. You know I'm from that zone 6. You know I rep that stone shit. You know your hood is so clear. As God as my witness, this Will Smith spit real.
Alright, for this question, we're asked to sketch the region enclosed by these two graphs, so x equals y times 4 minus y, and our x equals 0, and then we're going to use the shell method to calculate the volume of rotation about the x-axis of this region. Okay, so first of all, we're supposed to graph these things, or sketch them at least. So let's look at, so x equals 0, that's simply the y-axis, so that one's going to be pretty easy, I would say, but our problem is this top function, so that is equal to x is equal to 4y minus y squared, okay? So I'm kind of getting it in a different form already. So this is kind of like saying negative y squared plus 4y plus 0. So what I'm going to do now is basically just complete the square so that I can get it into a more workable form in order to graph. So we're going to take out a negative. So that means we have a negative and then y squared and then minus a 4y, okay? And then plus 0. And now I'm going to complete the square here. So x is equal to negative y squared minus 4y. And if you divide this b, or the second term, by 2, so that'd be a negative 2 when you square it, then you have a positive 4 there. But it's kind of like we just added in a negative 4, so I'm going to write a plus 4 outside. Anyway, so I just completed the square here so that I can do negative of y minus 2 and then squared plus 4. Okay, so this is in graphable form. This tells us this negative here. So something to start off with. I'll start on the next slide by explaining that x equals y squared is basically this graph here. It's going to be a sideways U, a rightward facing U. It opens up to the right. And now, so this is the original one, but now our function looks like x equals negative y minus 2 squared and plus 4. Okay, so this negative means that it's flipped around. So we're pointing to the left instead. It's leftward opening. Okay, and then this means that it is actually not moved down 2, but it is moved up 2. So up 2. So this is going to be moved up 2, okay? And this means to the right 4, okay? So to the right 4. This is just graphing stuff. It might be a little bit weird because we're graphing a function of y instead. But anyways, so this is what it looks like. And this is, okay, so we're going to, our origin is actually, or the base of our u is going to be 4, 2. Okay, so we're going to start at 4, 2, and then we're going to open it up to the left, okay? So what it's going to look like is this. So we have some function like this, so x, and then our y. So we're going to have 1, 2, 3, 4, 5, 6, just in case. So there's 2 and there's 4. 1, 2, 3, 4, 2, and 4. Okay, so here's our base. We're starting it here, and then we're going to, there's no factor in front, so this is just a 1, so that means if we go up 1, we're going to go to the left 1. Okay, because it's leftward facing, right? So something like this, and then it's going to cross here and here as well. So we have a parabola that's facing to the left, okay? So it opens up like such. Okay, so now that we have that, this is our original graph, which was x is equal to y times 4 minus y, right? And then here's x equals 0. Okay, so this is our x equals 0. So that means here's our region in here that we want to graph, okay? So if we're looking in there, now we have to rotate this thing about the x-axis, which is kind of weird, right? But here we're going to use shell method, so that means we're going to have, so this is our axis of rotation. Okay, what we want to do is rotate this guy around the x-axis. So that means we're going to draw our cylinders, right? So cylinders like this. So this is our radius, and this is the height. Okay, so therefore we're going to have cylinders that kind of look sideways, right? So our radius is actually just going to be our y, the y height. So radius is equal to y. And then height is a little bit different. So height is going to be this function here. So that just means that's actually just our normal function. So that'll be our y times 4 minus y, the given function there. But this is actually, we can just write it 4y minus y squared, just for convenience. Okay? Also, and then we need to know our y interval because we want an interval on y, and then we're going to use our dy as the thickness. So we can see from the graph that it's 0 and 4, but let's actually like plug it into the formula to see how to solve for that. So x is equal to y times 4 minus y is one of our graphs, and then x equals 0 is another one. So what we can do is just find where these two are equal, where they intersect. So if we do that, then we get 4y minus y squared is equal to 0 when we can take out that y, so that's 4 minus y. So that equals 0 when y is equal to 0 or 4. Okay, so we have 0 and 4 here. So here's all of the information that we'll need in that bottom right corner. Okay, so let's plug that in on the next slide. So we have radius, I'll put a capital R, radius is equal to y. Okay, our height is equal to a 4y minus y squared. Our interval is 0 to 4, and we're using dy as our thickness. Okay, so our volume is then going to be 2 pi times the integral from 0 to 4 of radius, y, times height, 4y minus y squared, times thickness, which is a dy. Okay, so let's continue here. So we get volume is equal to 2 pi times the integral from 0 to 4 of 4y squared minus y cubed, and then dy. So we're going to integrate, and we get 2 pi times, and we have 4 over 3 y to the third. Okay, and then minus 1 over 4 y to the fourth, and then evaluating this from 0 up to 4. Okay, so let's simplify a little bit. We have 8 pi over 3 times y cubed, and then a minus pi over 2 y to the fourth, evaluated from 0 to 4. So if we start evaluating this, we get v is equal to 8 pi over 3 times 4 to the third minus pi over 2 times 4 to the fourth minus, and then we're going to have minus a 0 here. Okay, so that goes away, and let's continue this on the next slide. So we have, we're at volume is equal to 8 pi over 3 times 4 to the third minus this pi over 2 times 4 to the fourth, and then we had minus 0. Okay, so simplifying this, we just get 4 to the third is a 64, so 64 times 8 pi, and then this is all over 3, and then minus, and this is a 256, I believe, because 16 times 16, so 256 pi over 2, okay? So this is going to be, this one's going to simplify to a 128, okay? And then on the left here, we just have this is 512 pi over 3 minus 128 pi, which, let's get that common denominator, so this is going to be 512 pi over 3 minus, and 128 times 3 turns out to be a 384, okay, and then pi over 3. So this, our volume, is ultimately going to be a 128 pi over 3, which is not divisible, but this is going to be our answer, okay? Alright, so that wraps up the practice problems video on the method of cylindrical shells. I hope that helps, and happy studying.
Drink with you as long as I can sing with you live. This shit my favorite song. You just don't know the words, but I still fuck with you. You just ain't never heard. It go like count that stack.